last lesson on trig. So there's nothing new. This is just practicing with word problems, and lots of times people have difficulty with the word problems because sometimes the diagram isn't there. So I cannot emphasize enough for all of these questions, you have to start with making a diagram first. Before I do questions 2, 3, 4, 7, and 9, and we're looking for those questions on page 86. Sorry, I didn't write that down. Those questions are on page 86. I actually want to do the example number 2 with you. This is a super common question. If you're going to be taking grade 11 math next year, you will most definitely run into this problem. It's the old finding the height of 2 buildings. So I have one building that is like this, and I have another building that is like that. First of all, we have to assume that these buildings are built properly and they're at right angles to the ground. So this question says to you, okay, the bases of the 2 buildings are 41.6 meters apart. From the roof of the shorter building, the angle of elevation to the top. So pretend you're standing on the top of the shorter building and you look up to the top. Remember, angle of elevation, and I don't know, I can't do this for you, is how far you have to look up. So I'm standing here. I actually have to raise my eyes up that high. This is the angle of elevation. So it's telling you that the angle of elevation, so how far you have to lift your eyes up from the horizontal. So if you're looking straight ahead and you've got to move your eyes up, that's your angle of elevation. So it tells you that the angle of elevation is 44 to the top of the taller building. Then it also says the angle of depression to the base of the taller building is 29. So angle of depression is the exact opposite. You're starting horizontal and it's how far do you have to look down. So this angle is you're looking straight across at the building and you need to look down. How far do you need to look down? You need to look down 29 degrees. And that's enough information to actually figure out how tall this building is. It doesn't look like a whole bunch of information, but it's enough. This is an example where you actually have to use 2 calculations. First calculation you're going to do is going to be to find this height. And if you know the height here, then you actually know the same height here. You have to assume that everything's built square. So if you can find this value of x, you actually know how tall the shorter building is. Okay, and then I can use this top triangle to find that distance. Okay, so the diagram is a little bit confusing. There's a lot on that diagram. Let's start with this bottom triangle. So I'm going to redraw the bottom triangle. When I redraw that bottom triangle, all right, this is what I'm looking to find. I want to find that height. I know that this angle is 29. Now remember, I did know that the distance between these 2 buildings was 41.6. That doesn't really help me, but again, that would mean that this distance is 41.6 meters. So you have to use the fact that they're built square, and this distance would be the same as that distance. Okay, so let's take a look at what we know for SOHCAHTOA. This we would assume is a right angle, so that's going to be my hypotenuse. Here's my angle of interest, so this is going to be my opposite. This is touching, that's going to be my adjacent. So SOHCAHTOA. I would like to know the opposite. I do know the adjacent. I don't know anything about hypotenuse, and I'm not asking you to find it, so we can get rid of hypotenuse, which means I'm left with the trig function of tan. So tan of 29 degrees equals opposite over adjacent. Tan of 29 degrees equals x over 41.6. I'm going to turn this into a fraction by putting it over 1. That way I can cross multiply and solve. X times 1 equals x, and I'm left with tan of 29 degrees times 41.6. So again, just give a quick check to make sure that your calculator is on degrees. Tan of 29. Most of you have this function on your calculator, so you don't actually even need to write this. I'll write it for you. We're always taking that to 4 decimal places. But on my calculator, I've got the answer. I'm just going to push times 41.6. And that's going to give me, let's do it to 1 decimal place. My number is 059. So that if I take a look at this, 59 is closer to 100 than 0. So then I'm actually going to round that number up. So that's going to equal 23.1. And my units are meters. Okay, so for this triangle here, this distance is 23.1 meters. Okay, which also means that this height of this shorter building is also 21.3 meters. So we're halfway done. Now what we're going to do is we're actually going to find this distance. And if I can find this distance using this second triangle, the triangle above, I can find y and I can add those two together. Okay, so I'm going to redraw my triangle again because there's a lot of, it's getting a little bit messy over there. Here's my redrawn triangle. Again, this base is the same as this one. So if this is 41.6, this is 41.6. I'm trying to find y, and I know that this angle is 44 degrees. Okay, so right angle here, that's going to be hypotenuse. If this is my angle of interest, that's the opposite, and this is the adjacent. Okay, so I don't know hypotenuse, and I don't care, so I'm left with tan. So the tan of 44 equals opposite over adjacent. Tan of 44 degrees equals y over 41.6, opposite over adjacent, just checking. Okay, I'm going to turn this into over 1. It's still the same value. That way I can now have a fraction equal to a fraction. Now I'm going to cross multiply and solve. 1 times y equals y, tan of 44 degrees. Okay, tan 44, and I get 40 point, and the number's 17. 7 is closer to 10 than 0, so the number before it is going to round up. So we'll say 40.2 meters. So this distance is 40.2 meters, and I think it's pretty fair to say that if I add those two things together, 40.2 plus 23.1 meters equals 63.3 meters. So therefore, the shorter building is, what did we say it was, 23.1 meters, and the taller building, at least this is faster than me writing on the board, is 63.3 meters. And so you've solved a very typical trigonometry question where you actually have to split the question up into two smaller parts, find values and add them together to get your overall answer. Okay, so for those of you who are going to be taking math next year, I'm almost sure, could almost guarantee that you're going to see that again.